Hello everyone, I am Plaksha Chaudhary and I am presenting my major project on the topic loan classification under artificial intelligence and machine learning. This project is about predicting whether a person who takes a loan will be able to repay it or will it be defaulted. It helps banks and financial institutions make better and faster decisions while giving loans to people. First, I have imported all the necessary Python libraries such as Pandas, NumPy, Matplotlib, Seaborn and Scikit-learn. Then I've tried to load the loan database from my computer using the pd.read CSV function, and it is stored in the df variable. If the file was not found, I have created dummy data using random numbers so that the program could still run smoothly. This step shows the project can handle missing or incorrect files properly using a try except block. After loading the data, I have displayed the first 5 rows using the data head function and data information using the df.info function. This contains 60 total columns and 41,188 rows. This helped me understand what kind of data was present, such as the number of columns, data types, and if there were any missing values. Next, I checked the target column, which shows whether the loan was repaid or defaulted. I used a count plot from Seaborn to see how many people repaid versus how many defaulted. This gave us a clear visual idea about the data balance, whether most people repaid or defaulted. I have also calculated the default rate by taking the average of the target column and multiplying it by 100. This gave me the percentage of people who defaulted on their loans. The overall default rate is 11.27%. After that, I have checked for missing values in the data set because missing data can reduce model accuracy. For numerical columns, I replaced missing values with the median. And for text columns, I have used the most common value mode. This process is called data imputation and it ensures that there are no empty cells in the dataset. Next, I have performed feature engineering to make the dataset more useful for the model. I created a new column called loan to income ratio by dividing the loan amount by the income. This feature helps understand how large the loan is compared to a person's income, which can indicate financial risk. Then I've converted all the text columns into numbers using one hot encoding with the help of pd.getDummies function. This machine learning model can only understand numbers, so converting text data is an important step. I also dropped the loan ID column because it is just an identifier and does not help in prediction. After these steps, my dataset was completely clean and ready for modeling. Then I divided the data into features X and output labels Y. This splitting of data was important. The input features include all the details like income, credit score, and employment years, while the output label shows whether the person repaid or defaulted. I split the data into training and testing sets using the train test split function. 70% of the data was used for training and 30% of it was used for testing. This helps in checking how well the model performs on unseen data. After splitting, I used the standard scaler function to scale all the numeric columns. Scaling helps so that large values like income do not dominate smaller ones like credit score. It brings all the numbers to a similar range, improving model performance. For the modeling part, I used Logistic Regression function, which is a good algorithm for binary classification problems like zeros and ones. It predicts the probability of whether an applicant will repay or default. I have also used class weight balanced to handle imbalanced data, meaning if one category has more samples than the other. Then I trained the model using the log model.fit function, in which we have xtrain and ytrain as parameters to make it learn from the training data. After training, I used the model to make predictions on the test data using predict function and predict proba function. The predict function gives the final output 0 for repay and 1 for default, while the predict proba gives the probability of defaulting. To check how well the model performs, I used several evaluation matrices. The ROC score measures how well the model can separate the two classes, repay versus default. A higher score means better performance. After running it, the ROC and ROC AUC score is 0.7704. I also printed the classification report, which shows accuracy, precision, recall, and F1 score. These values help us understand how well the model is identifying actual defaulters and repairs. Next, I have plotted the confusion matrix. We're using Seaborn's heat map. This matrix visually shows the number of correct and incorrect predictions for both classes. For example, how many people were correctly predicted as repairs and how many were misclassified. Finally, I plotted the ROC curve, which shows the relationship between the positive rate and the false positive rate. It helps visualize how good the model is at distinguishing between defaulters and repair. Thank you.